Hello, geometry students. I hope you are looking forward to your first e-learning lesson. We are going to begin a new unit on circles, and our first lesson is going to be about the lines and segments that intersect circles. So the first thing we need to do is talk about the parts of a circle. We have some vocabulary to talk about. So this is all written up in your notes. Again, you have the option of printing out your notes and doing this along with me. You can download it to an iPad and write on it a Notability, which is what I'm doing to make this video. You do have touchscreen Chromebooks, so you could download it, and I think there is something called Kami, an app that you can download where it allows you to write on a PDF, or feel free to just get a piece of scrap paper and write along with me. All right, so here are our vocabulary for this particular section. The first thing we want to look at is what is a radius. And how do you determine a radius? You look at where the endpoints are located. The endpoint of a radius is located in the center of the circle, and the other endpoint is located on the circle. If I look at a chord has endpoints, and they are both on the circle. A special type of chord is the diameter. So the diameter is special in a few ways. First of all, it's a chord. It is a chord because it has endpoints on the circle, but it also goes through the center. So that's why if you are being asked for the most specific type of segment on the circle, you would not call this a chord, you would call it a diameter whenever it goes through the circle. So let me kind of get rid of some of that. All right, so also notice that a diameter also consists of two radii. Next, we need to talk about a secant. A secant is a line, and it is a line that goes through the circle and it hits the circle twice. Now, it does contain a chord. This piece of it right in here where I have endpoints on the circle, okay, that is a chord. But a secant is the line containing that chord. A tangent is also a line, and instead of it hitting the circle once, a tangent hits the circle, instead of hitting the circle twice like a secant, a tangent hits the circle once. That's what makes it a tangent. So that was kind of a drawing approach. All right, here, this is everything that you need to know in written form from your notes. So again, a segment whose endpoints are the center and any point on the circle, that's your radius. A chord has endpoints on this circle, and a diameter is a special type of chord that contains the center. A secant, it is a line, guys. It's a line, it's a line, it's a line that intersects twice. And a tangent is a line that intersects once. And that one place where it hits is called the point of tangency. So in our previous example, this would be our point of tangency. All right, so let's answer a couple of homework problems. Pardon me. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. This is how you name a circle. You would just draw a circle with a dot in the middle, and then whatever capital letter comes after it denotes what the center of the circle is. Okay, AC, so let's look at AC. You have to notice where you have the endpoints. One endpoint is the center, one is on the circle, and therefore that makes it a radius. Next, AB. I'm noticing that my endpoints are on the circle, but it goes through the center. So that would make it most specifically a diameter. Next, they want to talk about radii. Okay, first of all, that is a segment on the outside of the circle. A radius, a chord, or a diameter, and the secant all have to go through. So part of it is process of elimination, but since this is hitting the circle on the outside, I would call that a tangent. It's hitting the circle once. And last but not least, they want us to look at AE. When I look at AE, the first thing I notice is that's a line. This is line AE. Well, a radius is not a line. A chord is not a line. A diameter is not a line. The only thing that can be a line is a secant or tangent. And because it's hitting it twice, I would call that a secant. So what word best describes AG? Well, let's take a look. If I look at AG, it is asking for friends. It's asking for a segment. So that means this cannot be a secant or a tangent if it's asking me to look at the segment. So when I look at AG, I notice that my endpoints are on the circle. So that makes this a chord. So that's what's huge. The difference between this problem and this problem, excuse me, is one is a line and the other is a segment. A line is a secant and a segment is a chord. All right, let's look at CB. Those are usually the easiest ones. It starts at the center, ends at the endpoint. So CB is a radius. Okay, let's erase some of this. All right, so the next question, it wants you to name a tangent. A tangent's a line. So, or it can be a ray. Let's go back and look at the definition. It says it's a line, but you can also say a tangent ray and a tangent segment are also called tangents. Oh my gosh, I went too far. Hello. Okay, here we go. Name a tangent and a tangent segment. So when it says a tangent, I'm going to stick by the original, let's call it a line. And so you can give me any two-letter combination of D, B, and E. And a tangent segment, you could give me any two-letter combination as well of D, B, and E, as long as you're hitting it one time. All right, as I stated in my introductory welcome video, if you didn't watch it, go ahead and watch it. Sometimes we're going to cut out certain problems, and this is one of those times. You can feel free to read this. I do have the notes from last year pulled so you can see it, but I did not ask any of these on your homework, so I'm going to save us some time and energy and move on to the problems that are on the homework. All right, so the first part of your homework is going to be to answer, is it a chord, is it a secant, is it a radius, is it a tangent, etc. The second part, or the types of questions, have to do with these two theorems. The tangent line to a circle theorem. What you need to know is that radii, which is the plural, radius and a tangent, you guys, they're perpendicular. Focus right here on this picture. Anytime you have a tangent and a radius, they should be perpendicular. And in the exterior triangles congruence theorem, tangent segments from a common external point are congruent. So it means RS and RT are congruent. And those are usually the easier problems. Theorem 10.1 problems are the ones that cause a little bit more stress. But if you can do Pythagorean theorem, you're just fine. All right, so how do we do our homework? They want to know if segment ST is tangent to circle P. So in order to figure this out, if I look at ST and I look at the radius, you guys, those have to be perpendicular. How do I test if they're perpendicular? Well, this has to be a right triangle. I have to figure out, are those perpendicular? If they're perpendicular, it should satisfy Pythagorean theorem. So, by the way, if I say something dumb or make a mistake, hang in there. I'll get better, but I'm just starting to make videos. So, we're just winging it here. All right, here we go. Remember that these are the legs and that C is your hypotenuse. So in this problem, 37 is the hypotenuse. It doesn't make a difference where you put 35 or 12. So I have 35 squared plus 12 squared equals 37 squared. Use your calculator. So I've got one on here, 35 squared plus 12 squared. That tells me that that's 1369. All right, let's figure out 37 squared. Also 1369? All right, so those agree. Therefore, ST is perpendicular to PT. Therefore, yes, ST is tangent to circle P. Second type of problem. There are several of this on the homework. This is really just an algebra problem. Once you get the hang of it, it's good. All right, it says in the diagram, point B is a point of tangency. That information tells us that we know that that is indeed a right triangle. They want you to find the radius R of circle C. All right, so let me erase that. Okay, here's what's going on. This is a leg. This is a leg. 50 is your hypotenuse. So when I set up Pythagorean theorem, the leg is R squared. The other leg is squared. But friends, the hypotenuse is not 50, it's not R. The entire hypotenuse from A to C, we have to use segment addition, and it is 50 plus R squared. So what does this mean when we solve it algebraically? Well, I have R squared, and then 80 squared, well, 8 is squared is 64 with 2 zeros. And friends, this means I have 50 plus R times 50 plus R. I can't just square the 50 and the R. I'm going to have to FOIL. Now, this looks like this is going to be awful, but have some faith. It's actually, stuff cancels out. It's not so bad. So I have R squared plus 6,400 equals 50 times 50 is 2,500. 50R, another 50R, and then plus R squared. Now this looks like it's going to be awful, but don't we have an R squared on both sides? So those would cancel out. So I am left with 6,400 equals 2,500 plus 100R. I'm going to subtract 2,500 from both sides. Oh my gosh, oh Lord, I already forgot what I was doing. 6,400 minus 2,500. Oh, didn't like that. On the struggle bus. Okay, so I get 3,900. That equals 100R. And when I divide both sides by 100, I get R is 39. So that is the radius of this circle. All right, here we go. RS is tangent to circle C at S, and RT is tangent to circle C at T. Find X. All right, we learned in a previous theorem that if I have a point that is tangent to the circle, those two segments have to be the same. So this is what I mean. These are usually the easier problems. Algebraically, all we have to do here is take, I am on the struggle bus today, guys, is to take 3x plus 4 equal to 28 and solve. So when I divide both sides by 3, we get that x is equal to 8. Okay, friends, we're just going to do those 3 problems again. So this is a point in where you could go ahead and maybe pause, do these problems, see if you can do them, and then you could fast forward the email or mute me to see if you could do them on your own. Does that make sense? All right, let's look at number 6. You can just keep watching normally. I just thought, just to give you an idea of how e-learning can look a little bit different than the classroom. Okay, I like 6. 6 is a little bit tricky. Okay, is DE tangent to circle C? All right, so let's look at this. If it is tangent, that means we have to have a right angle there. And if that is a right angle, then it should satisfy Pythagorean theorem. All right, well, this is 3 is one leg, 4 is another leg, but be careful on your hypotenuse. The hypotenuse is from C to E. And kids are like, well, Nap, I don't know what this is. Yes, you do. All radii are congruent. So if this is 3, this has to be 3. So that makes my total 5. And friends, you can do the work, but we should recognize that as a Pythagorean triple. So this is 9 plus 16 is equal to 25. 25 is equal to 25. So is DE tangent to C? Yes, because CD is perpendicular to DE. All right, friends. ST is tangent to circle Q. Find the radius of Q. All right. So again, we're going to do some Pythagorean theorem and we're going to have some algebra to do. So again, this is a leg. So that's r squared. This is another leg, 24 squared. But when I do the hypotenuse, I have to use segment addition, and it's r plus 18, and I have to square it. So what does that mean? I have r squared plus 24 squared, and that is r plus 18 times r plus 18. Write it twice in FOIL. All right, so if you don't know 24 squared is 576. And then r times r is r squared plus 18r plus another 18r. And then 18 times 18 gives me 324. What should happen every time is that you should see the r squareds cancel. So it shouldn't be a quadratic when you're done, even though it looks like a scary problem. The hardest part, or I wouldn't even say hardest, but is that you have to remember that r plus 18 squared has to be written twice and FOILed. All right, so 576 is equal to 36r plus 324. I'm going to subtract 324 from both sides. So 576 minus 324. 576 minus 324 gives me 252. Divide both sides by 36. Oh, nope, that didn't work. I thought it would work, and it didn't. 252 divided by 36. And that gives me a final result of 7. And let's box that up. And last but not least, and we're done with our first e-learning video, points M and N are points of tangency. Find the value of X. The real issue here is that you have to remember via the theorem that the distance from M to this point and the distance from N to that point are the same. So X squared is equal to 9. And don't forget that when you solve by square roots, you get 2 answers. All right, friends. So what is your learning opportunity? Your learning opportunity, which should be in a separate post on Google Classroom, is Unit 10, Lesson 1 practice. It is a front and a back, so it's 2 sides. Let's get this together, Nap. It's 2 sides, and I expect you to do them, take a picture, and upload it to Google Classroom. Please note that I do have not only the answers posted for you, but I did work out the answers, and I put them as well. I hope you enjoyed your e-learning, and hang in there. I'm thinking of all of you, and you will have your next video come out next Monday. Cheers.